Book 10, Chapter 2 of 10 Books on Architecture. This LibriVox recording is in public domain. Recording by Fredrik Karlsson. 10 Books on Architecture by Vitruvius. Translated by Morris Hickey Morgan. Chapter 2. Hoisting Machines. 1. First we shall treat of those machines which are of necessity made ready when temples and public buildings are to be constructed. 2 timbers are provided strong enough for the weight of the load. They are fastened together at the upper end by a bolt, then spread apart at the bottom, and so set up, being kept upright by ropes attached at the upper ends and fixed at intervals all round. At the top is fastened a block, which some call a rechamus. In the block 2 sheaves are enclosed, turning on axles. The traction rope is carried over the sheave at the top, then let fall and passed round a sheave in a block below. Then it is brought back to a sheave at the bottom of the upper block, and so it goes down to the lower block where it is fastened through a hole in that block. The other end of the rope is brought back and down between the legs of the machine. 2. Socket pieces are nailed to the hinder faces of the square timbers at the point where they are spread apart, and the ends of the windlass are inserted into them so that the axles may turn freely. Close to each end of the windlass are 2 holes, so adjusted that handspikes can be fitted into them. To the bottom of the lower blocks are fastened shears, made of iron, whose prongs are brought to bear upon the stones which have holes bored in them. When one end of the rope is fastened to the windlass, and the latter is turned round by working the handspikes, the rope winds round the windlass, gets taut, and thus it raises the load to the proper height and to its place in the work. 3. This kind of machinery, revolving with 3 sheaves, is called a trispast. When there are 2 sheaves turning in the block beneath and 3 in the upper, the machine is termed a pentaspast. But if we have to furnish machines for heavier loads, we must use timbers of greater length and thickness, providing them with correspondingly large bolts of the top, and windlasses turning at the bottom. When these are ready, let 4 stays be attached and left lying slack in front. Let the backstays be carried over the shoulders of the machine to some distance, and, if there is nothing to which they can be fastened, sloping piles should be driven, the ground rammed down all round to fix them firmly, and the ropes made fast to them. 4. A block should then be attached by a stout cord to the top of the machine, and from that machine a rope should be carried to a pile, and to a block tied to the pile. Let the rope be put in round the sheave of this block, and brought back to the block that is fastened at the top of the machine. Round its sheave the rope should be passed, and then should go down from the top and back to the windlass, which is at the bottom of the machine, and there be fastened. The windlass is now to be turned by means of the handspikes, and it will raise the machine of itself without danger. Thus a machine of the larger kind will be set in position, with its ropes in their places about it, and its stays attached to the piles. Its blocks and traction ropes are arranged as described above. 5. But if the loads of the material for the work are still more colossal in size and weight, we shall not entrust them to a windlass, but set in an axle tree held by sockets as the windlass was, and carrying on its centre a large drum, which some term a wheel, but the Greeks call it amphisis or peritekion. 6. And the blocks of such machines are not arranged in the same but in a different manner, for the rows of sheaves in them are doubled, both at the bottom and at the top. The traction rope is passed through a hole in the lower block, in such a way that the 2 ends of the rope are of equal length when it is stretched out, and both portions are held there at the lower block by a cord which is passed round them and lashed so that they cannot come out either to the right or the left. Then the ends of the rope are brought up into the block at the top from the outside and passed down over its lower sheaves, and so return to the bottom, and are passed from the inside to the sheaves in the lowest block, and then are brought up on the right and left and returned to the top and round the highest set of sheaves. 7. Passing over these from the outside, they are then carried to the right and left of the drum on the axle tree, and are tied there as to stay fast. Then another rope is wound round the drum and are carried to a capstan, and when that is turned, it turns the drum and the axle tree. The ropes get taut as they wind round regularly, and thus they raise the load smoothly and with no danger. But if a large drum is placed either in the middle or at one side, without any capstan, men can tread in it and accomplish the work more expeditiously. 8. There is also another kind of machine, ingenious enough and easy to use with speed, but only experts can work with it. It consists of a single timber, which is set up and held in place by stays on 4 sides. Two cheeks are nailed on below the stays, a block is fastened by ropes above the cheeks, and a straight piece of wood above 2 feet long, 6 digits wide, and 4 digits thick, is put under the block. The blocks used have each 3 rows of sheaves side by side, hence 3 traction ropes are fastened at the top of the machine. Then they are brought to the block at the bottom and passed from inside round the sheaves that are nearest the top of it. Then they are brought back to the upper block and passed inwards from outside round the sheaves nearest the bottom. 9. On coming down to the block at the bottom, they are carried round its second row of sheaves from the inside to the outside and brought back to the second row at the top, passing round it and returning to the bottom. Then from the bottom they are carried to the summit, where they pass round the highest row of sheaves and then return to the bottom of the machine. At the foot of the machine a third block is attached. The Greeks call it epagon, but our people artemon. This block, fastened at the foot of the machine, has 3 sheaves in it, round which the ropes are passed and then delivered to men to pull. Thus 3 rows of men, pulling without a capstan, can quickly raise the load to the top. 10. This kind of machine is called a polyspast, because of the many revolving sheaves, to which its dexterity and dispatch are due. There is also this advantage in the erection of only a single timber, that by previously inclining it to the right or left as much as one wishes, the load can be set down at one side. All these kinds of machinery described above are in their principles suited not only to the purposes mentioned, but also to the loading and unloading of ships, some kinds being set upright and others placed horizontally on revolving platforms. On the same principle, ships can be hauled ashore by means of arrangements of ropes and blocks used on the ground, without setting up timbers. 11. It may also not be out of place to explain the ingenious procedure of Chersiphron. Desiring to convey the shafts of the temple of Diana at Ephesus from the stone quarries, and not trusting to carts, lest their wheels should be engulfed on account of the great weights of the load and the softness of the roads in the plain, he tried the following plan. Using 4-inch timbers, he joined 2 of them, each as long as the shaft, with 2 cross pieces set between them, dovetailing all together, and then leaded iron gudgeons shaped like dovetails into the ends of the shafts, as dowels are leaded, and in the woodwork he fixed rings to contain the pivots and fastened wooden cheeks to the ends. The pivots, being enclosed in the rings, turned freely, so, when yokes of oxen began to draw the 4-inch frame, they made the shaft revolve constantly, turning it by means of the pivots and rings. 12. When they had thus transported all the shafts, and it became necessary to transport the architraves, Chersiphron's son Metagenes extended the same principle from the transportation of the shafts to the bringing down of the architraves. He made wheels, each about 12 feet in diameter, and enclosed the ends of the architraves in the wheels. In the ends he fixed pivots and rings in the same way. So when the 4-inch frames were drawn by oxen, the wheels turned on the pivots enclosed in the rings, and the architraves, which were enclosed like axles in the wheels, soon reached the building, in the same way as the shafts. The rollers used for smoothing the walks in palaestrae will serve as an example of this method, but it could not have been employed unless the distance had been short, for it is not more than 8 miles from the stone quarries to the temple, and there is no hill, but an uninterrupted plain. 13. In our own times, however, when the pedestal of the colossal Apollo in his temple had cracked with age, they were afraid that the statue would fall and be broken, and so they contracted for the cutting of a pedestal from the same quarries. The contract was taken by one Paconius. This pedestal was 12 feet long, 8 feet wide, and 6 feet high. Paconius, with confident pride, did not transport it by the method of Metagenes, but determined to make a machine of a different sort, though on the same principle. 14. He made wheels of about 15 feet in diameter, and in these wheels he enclosed the ends of the stone. Then he fastened 2-inch crossbars from wheel to wheel round the stone, encompassing it, so that there was an interval of not more than 1 foot between bar and bar. Then he coiled a rope round the bars, yoked up his oxen, and began to draw on the rope. Consequently, as it uncoiled, it did indeed cause the wheels to turn, but it could not draw them in a line straight along the road, but kept swerving out to one side. Hence it was necessary to draw the machine back again. Thus, by this drawing to and fro, Paconius got into such financial embarrassment that he became insolvent. 15. I will digress a bit and explain how these stone quarries were discovered. Pixodorus